All right, welcome back. We are on ACT Prep Unit 3, Elementary Algebra Topics. Today is day 5. We're talking about factoring polynomials. So factoring polynomials. Factors of polynomials are expressions whose product equals the polynomial. So if you were saying, let's say we had x plus 2, we're working backwards is what we're doing. If I multiply these two together, I would get x squared plus 3x plus 2x, which is plus 5x plus 6. Today what you're doing is you're going to start with things like this and have to back up and figure out what got multiplied together to give you that polynomial. Okay? So the first technique we're going to learn for factoring is what you should always look for first. And that is to look for a GCF. Okay? And what you do is you figure out what the GCF is, and your answer is whatever the polynomial, it factors into your GCF times what's left. Okay? So, it says factor this. Well, the first thing I think of when I see the word factor is I look for a GCF, a greatest common factor. And what I do is I take the numbers 35, 14, 63, 84, and I try and figure out the biggest number that will go into all of those. Now, what I suggest is sometimes, this kind of backfires sometimes, but if you take the smallest number and you see, is that a factor? Does 14 go into 35, 14, 63, and 84? Well, I know it doesn't go into 35 because there's nothing times 4 that ends in a 5, so it can't be 14. But it can't be anything bigger than 14 either, because you can't have something bigger than your smallest number being a factor. So it's got to be smaller than 14. So 13, no. 12, it might go into some of them, but I know it won't go into 35. 11, no. 10, no. 9, no. Well, 9 goes into 63, but nothing else. 8, no. 7, yeah. 7 goes into 35 5 times, 7 goes into 14 twice, 7 goes into 63 9, 7 goes into 84 12 times. Okay, so I've got my GCF for the numbers is 7. Okay, next you're going to look at the variables. Okay, so my variables, I have x to the 7th, y to the 8th, x to the 2nd, y to the 5th, x to the 8th, y to the 3rd, and x to the 5th, y to the 9th. And again, people, it says find the greatest common factor. So people think that they're looking for something big, but we're not. We're looking for actually, because what they have in common, like he has 7 x's, he only has 2 x's. So they don't have 7 in common, they would only have 2 in common. So you're actually looking for the smallest exponent. So my greatest common factor of the x's is going to be x to the 2nd. My greatest common factor of the y's is going to be y to the 3rd. So that makes an x squared y cubed. So my GCF for this group is 7x squared y cubed. So when I factor this, it's going to be my GCF, 7x squared y cubed, times what's left. To get what's left, you divide every term by the GCF. So I'm going to divide by 7x squared y cubed, 7x squared y cubed, 7x squared y cubed, 7x squared y cubed. And whatever's left is your remaining factor. So 35 divided by 7 is 5. X to the 7 minus 2 would be x to the 5th. Y to the 8 minus 3 would be y to the 5th. Positive 14 divided by positive 7 is positive 2. X to the 2 minus 2 is x to the 0. Y to the 5 minus 3 is y to the 2nd. Next, I have a negative 63 divided by a positive 7 is a negative 9. X to the 8 minus 2 is x to the 6th. Y to the 3 minus 3 is y to the 0. And I didn't do red yet. Positive 84 divided by 7 is positive 12. X to the 5 minus 2 is x cubed. Y to the 9 minus 3 is y to the 6th. And you're done except for cleaning it up. Okay, anything to the 0 degree is 1. So that's 1 and that's 1. So I have 7x squared y cubed times 5x to the 5th y to the 5th plus 2y squared, because 2 times 1 times y squared is just 2y squared, minus 9x to the 6th plus 12x cubed y to the 6th. And I'm done. Have you solved anything? Have you found anything? No. If I multiply this back out, I'm going to get what I started right back. It's just like saying instead of 12, I'm saying 2 times 6. Does it look different than 12? Yeah. Is it worth the same? Yeah. I didn't do anything different. I just wrote this as a product of two other things. And that's all you did here. I didn't change this. I didn't increase it. I didn't decrease it. All I did was rewrote it as something times something else. If you distributed that back out, you'd end up with your original answer back. Okay? So for 2, all right, if I get my numbers, I have a 49, a 24, a 10, a 1, and a 14. Well, you gotta love it when you start with your lowest, your greatest common factor can't be bigger than your smallest number. So, gee, my GCF is gonna be 1. Okay? My letters, I've got a z cubed x to the 1st, I've got a z to the 5th, x to the 3rd, I got a z to the 2nd, x to the 6th, I got a z to the 3rd, x to the 1st, and I got a z to the 2nd, x to the 6th. So I'm looking for the smallest degree. The smallest degree on z is a 2. The smallest degree on x is a 1. So z squared x, my GCF, is 1 z squared x, which I can just write as z squared x. So my GCF is z squared x, and that's to get what's left, I divide every term by z squared x, z squared x, z squared x, z squared x, z squared x. Okay, and now to get what's left then, 49 divided by 1 is 49. Z to the 3 minus 2 is z to the 1st. X to the 1 minus 1 is x to the 0. Negative 24, z to the 5 minus 2 is z cubed. X to the 3 minus 1 is x squared. Positive 10, z to the 0, x to the 6 minus 1 is 5. Minus z to the 3rd divided by z squared is z to the 1st. X to the 1 minus 1 is 0. Plus 14, z to the 2 minus 2 is 0. X to the 6 minus 1 is 5. And I'm done, other than cleaning up the 0 degrees, because those are just ones. So my final answer would be z squared x times 49z minus 24z cubed x squared plus 10x to the 5th minus z plus 14x to the 5th. Hey, I can combine my terms, actually. These guys now match. Well, I'm a schmo. We could have combined those from the very beginning. So, yeah, be careful. I didn't catch that. So it has z squared times 49z minus 24z cubed x squared. 10 and 14 is 24x to the 5th minus z. Be careful, I almost missed that. Alright. Factoring completely. Alright, this is what we call, well, when I say we, I mean me. Okay, when you see this, you got like something times something over here plus a product over here. What you're looking for when they do this to you is you're looking for the same set of parentheses of junk on both sides of that plus sign. And right now, none of the junk matches. Okay? But if I look at this first set of parentheses, again, always check to see if there's any kind of PEMDAS you can do first. I notice I can combine x's, which would give me 3x, and I can combine constants, which would give me positive 4, times 2x minus 2 plus 3x plus 4 times 5x minus 1. Now, what's neat is if you look at this, and again, you're looking at both sides of this plus sign, and you're looking for matching junk. Well, I got matching junk on both sides. Each side is being multiplied by 3x plus 4. So guess what that means? Oops, don't need a highlighter in purple. What that means is my GCF is 3x plus 4. So my answer is going to be my GCF times what's left. Well, what's going to be left is what happens if I divide both sides of that plus sign by 3x plus 4. Well, it cancels out here and leaves 2x minus 2. It cancels out here and leaves plus 3x plus 4. So that would be my answer, but I can clean up this set of parentheses, combine like terms. That would be 5x. That would be plus 2. So my answer is 3x plus 4 times 5x plus 2. Okay? Okay, to factor by grouping. Usually this technique is when you see 1, 2, 3, 4 terms. Okay? And be careful here. I could actually combine these two. And this is what's irritating about this, where I got this information from. They kind of did it out of order. If I combined those two middle terms, I would get plus 17wz minus 7z squared. And in the next, tomorrow, or on day 6, or whatever we're on, day 6, I'm going to teach you how to factor what we call a general trinomial, okay? But, so, yeah, it's hard. I'm going to preach at you and say, always look for PEMDAS first. Except for today, because if you do PEMDAS first, you're going to combine those, and I'm not teaching general trinomial factoring yet. So, for today, okay, when you see 4 terms, go for grouping first instead of GCF first. Or, combine like terms first. So, this technique is called grouping. And my little song goes 2 by 2, just like Noah. Animals came on the ark 2 by 2, yeah? So 2 by 2, what that means is you literally split that polynomial in half. So I'm going to have 12w squared minus 4wz. There's half of the polynomial. And I'm going to split it, and I'm going to put the plus 21wz minus 7z squared in a different color, just so that you can kind of see that split there. Okay? Then what you do is you GCF, GCF, GCF again. Woo! Sing the song, it makes you happy. Alright, so if I GCF over here, I'm trying to figure out what the greatest common factor, and you can write it all out, but hopefully the numbers are small enough. Always check the smallest number first. Does 4 go into both of them? Yes, so my GCF is 4. And what letters do they have in common? 2 copies of W or 1. Remember, we always take the smallest. And he has a Z and he doesn't, so it's not a common factor. So my GCF is 4W. To get what's left, I divide both sides, or both terms, by 4W. And that will leave 12W squared divided by 4W is 3W. Negative 4WZ divided by 4W is just going to leave negative Z, because the 4's and the W's cancel. Okay, my next side, my other side, you GCF over here. That's what, so I GCF'd here. Now I'm GCFing over here. And what they have in common, the biggest, check the smallest number, 7 will go into both of them, so I'm going to pick a 7. And they have 1 copy of Z. Now you've got to take a sign here, or it's not going to make any sense. And I promise you, 99% of the time, if you'll copy this guy's sign instead of his, you'll be alright. So I'm going to go for a positive 7Z. And to get what's left, I divide by a positive 7Z. And what's left, when I do that, over here, on this side, I need to find a color, sorry. Alright, positive 21 divided by positive 7 is positive 3. The Z's cancel and I have W. Over here, negative 7 divided by positive 7 is negative 1. Z squared divided by Z to the first is Z to the first. And you're going to notice, now what we're going to do is we're going to GCF again. Alright, and what you do is you look for the matching binomial. If you don't get a matching bino after you 2 by 2, GCF, GCF, if you don't have anything that matches, one of two things happened. Either you messed up, or the polynomial's prime and can't be factored in the first place. All right, but this one, we do have a GCF again. It's 3w minus z. So my final answer is going to be my GCF times what's left. And to get what's left, you divide by your GCF. And what I get is what's left in green. So my other binomial is going to be 4w plus 7z. Done. And if you multiplied this back out before you combine like terms, you will get that polynomial. Okay? Alright, so we've got some special factors. We have difference of squares. And this is when your first term is perfect, your second term is perfect, and it's a difference in between. And when you get difference of squares, that factors into bino, plus, and minus. And there's a little song to help you remember that, which we'll do this in a second. But when you have perfect squares, you have the first term's a perfect square, the second term's a perfect square, and the middle is the relationship between an x times a y doubled. Okay, sum of cubes, bino, trino, plus, minus, plus. Difference of cubes, bino, trino, minus, plus, plus. Those are the little sayings to help you remember these special factors. Okay, and these are two particular favorites. Okay, memorizing these methods are going to save you a lot. Not so much the perfect squares, but. Okay, so difference of squares. First of all, you got to check and make sure that you have difference of squares. So my first clue that I'm dealing with difference of squares is that there's only two terms and there's a minus sign. If that happens, I check and I see. So to make sure they're perfect, just try and square root and make sure you don't get a decimal. So the square root of 81x squared is 9x. So that's perfect. The square root of 64y squared is 8y. So they are perfect. Check. If they're perfect, then you're ready to sing the song, which is bino, plus, and minus. See how the song goes? Bino, so you make two groups, plus the first one's going to be a sum, the second one's going to be a difference. And what you put in there are your roots. So this factor is going to be 9x plus 8y, and this one's going to be 9x minus 8y. Done. Okay? Two terms and a minus sign make me think difference of squares, so I got to check. Square root of 144 is 12. Square root of 0.25y squared would be 0.5y. And again, check it, use a calculator, type in the square root of 0.25, it'll tell you 0.5. So it is perfect, which means I got a bino, plus, and minus. And my terms are going to be those guys. So I got 12 plus 0.5y and 12 minus 0.5y. Done. Okay? Your perfect squares are kind of a pain in the butt to check. Okay? If you have a perfect square, to recognize them, you got to kind of be able to picture, first of all, check the ends. They've got to be perfect squares. If they're not perfect squares, then don't bother. Then the trinomial isn't perfect. Okay, but if the ends are perfect, then you got to check one more thing. So if I check the ends, square root of 16x squared is 4x. The square root of 25y squared is 5y. So they are perfect, but you got to check one more thing. If I take this root and this root and double it, so 4x times 5y would be 20xy. Double that. Oh, I know what I was going to say. Here's how you check the second thing. So now you have to say, does the middle, 40xy, equal 2 times what I just circled? So does it equal 2 times 4x times 5y? This would be 8x times 5y would be 40xy. So yes, it matches, which means it's perfect. So once you know that it's perfect, The rule for if they're all pluses, okay, is everything's going to be plus. So it's going to be two binos, plus and plus. And your terms are these guys. So you have 4x plus 5y, 4x plus 5y, and then they write it, since it's the same thing times itself, instead of writing it like that, they write 4x plus 5y squared. Okay, so 2, if I check the bottom one, check your ends. The square root of 4x squared is 2x, perfect. The square root of 81 is 9, perfect. Does the middle term, 36x, equal 2 times what I put in circles? So 2 times 2x times 9. 2 times 2x is 4x, times 9 is 36x. It checks, so we're good. Bino, two pluses, and my roots are, or my terms are 2x and 9, which gives me 2x plus 9 squared. Okay, so there's your perfect squares. All right, your sum of cubes. Okay, bino, trino, plus, minus, plus. And what you do is, this only works if you have the sum of perfect cubes. So you got to check them first. I got the cube root of 8x cubed, which would be 2x. And again, if you don't know your cube roots, on your calculator, hit your math key, and you want choice 4. That'll give you a cube root on your calculator screen. So if you hit math 4, and then type in 8. Don't type in the x cubed. That'll just do the number. You can do the letter in your head, but the cube root of 8 is 2. Okay, so that one's perfect. And I got to check the last one. The cube root of 27y cubed would be 3y. Again, if you do the cube root of 27, the calculator will tell you 3y, or 3. Okay, so it's perfect, which means I sing my song. I'm going to have a bino, I'm going to have a trino, and my signs are going to be plus in the first one and minus plus in the second. Bino, trino, plus, minus, plus. Okay, remember that song. It works. I've remembered it for years. Your terms in the first one are the 2x and the 3y. To get the terms in the trino, to get the ends, you square these guys. So 2x squared would be 4x squared. 3y squared would be 9y squared. To get the middle term, all you do is multiply those two together. So I'd have 2x times 3y, which is 6xy, and I'm done. Okay? So if I try this one, let's see if it's perfect. The cube root of 64 is 4. The cube root of 8y cubed is 2y, so they are perfect, which means I get to do bino, trino, plus, minus, plus. My terms for the bino are 4 and 2y. Square them to get the first and the last terms of the trino. 4 squared is 16. 2y squared is 4y squared. And we multiply the 4 times the 2y, which is 8y, to go in the middle. And we're done. Okay, difference of squares, bino, trino, the only thing difference is the signs. If it's a difference of cubes, the signs go minus, plus, plus. So we're still checking. I got the cube root of 125x cubed, which is going to be 5x. I have the cube root of y cubed, which is going to be y. So they are perfect. Bino, trino, minus, plus, plus. Again, these go in the bino, so 5x minus y. Square them for the trino. 5x squared is 25x squared. Y squared is y squared. And to get the middle, you multiply 5x times y, which is 5xy. Done. Okay. Number 2, I got to see if they're perfect. The cube root of 0.008x cubed. Again, type in the cube root of 0.008, and it will tell you 0.2 x. Cube root of x cubed is x. Okay. And then the cube root of 27 is 3, so it is perfect, which is going to give me bino, trino, minus, plus, plus. My terms for the bino are 0.2x and 3. To get the trino, you square these. If I square 0.2, I get 0.04 x squared, and 3 squared is 9. And if I take these two and multiply them together, 0.2x times 3, I get 0.6x. So it'll be 0.6x. And I'm done. Alright, so you tried this one, hit pause, come back when you're ready. And hopefully you got B. Okay, I'm looking at this and there's 3 terms, so I'm thinking always first check for GCF. And I'm looking at a 12, an 18, and a 30. I'm going to start with the smallest number. 12 doesn't work. 11, no. 10, no. 9, no. 8, no. 7, no. 6, yes. So 6 is going to be my GCF. My letters, what do I got? I got x to the 4th, y, I got to the 1st. X to the 3rd, y to the 2nd, x to the 2nd, y to the 1st. So I'm going to pick my smallest. Smallest exponent on x is a 2, smallest on y is a 1, so it's x squared y. So my GCF is 6x squared y. So I divide by that. My GCF is 6x squared y. So to get what's left, I'm going to divide by it. And I will get, give me just a second, I'm going to get 2x to the 2nd, y to the 0, because 1 minus 1 is 0. The next one, 18, divided by 6 is positive 3, x to the 1st, y to the 1st, because 3 minus 2 is 1, 2 minus 1 is 1. And negative 30 divided by 6 is negative 5. I hate it when it does that. Negative 5, x to the 2 minus 2 is 0, y to the 1 minus 1 is 0. And that's my answer, except for they don't write anything to the 0 degree, because anything to the 0 degree is 1. So I would have 6x squared y times 2x squared plus 3xy minus 5. And there you go. Alright, try this one. Hit pause. Come back when you're ready. Alright, and hopefully you got H. Alright, I see 4 terms, and again, normally I would combine like terms first, but they're kind of backwards here. So I see 4 terms, so my instinct is to go 2 by 2. So I have 2x squared minus 2x, and then I have plus 3x minus 3. So I split it 2 by 2. Then I'm going to GCF over here. Biggest number is a 2 and 1 copy of x. So 2x. To get what's left, you divide by it. And that's going to give me x minus 1. Okay, on the other side, my GCF over here is a 3. So I have 3. To get what's left, I divide by it. And what's left is going to be 3x divided by 3 is x. Negative 3 divided by 3 is negative 1. So now I'm going to GCF again, which your GCF again is the matching bino. So mine is x minus 1. So x minus 1. To get what's left, you divide by x minus 1. And what's left is what's green, which is 2x plus 3. Okay? Alright, so factor completely. On this one, let's see if this is the one that I screwed up on. I actually did the whole 2 by 2 thing first, and it works, but in this particular case, I didn't get a matching bino when I did the 2 by 2 GCF, and when you don't get a matching bino, it means it can't be factored that way. So in this particular case, I noticed that the end terms are the same and the middle terms are the same. If it's just the middle terms that match, don't combine like terms first, do the grouping thing. But if you, like I said, my instinct here was to do grouping, but then I noticed that you have, the outer terms are the same too. So then I decided, nah, PEMDAS first. So if I do 4x to the fourth and 2x to the fourth, I get 6x to the fourth. And then these match, so 10 of them minus 2 of them would leave 8x to the fourth y squared. So now I have two terms, but they're not difference of squares clearly. So I'm thinking GCF. You always want to start with GCF usually, okay? So let's see, 6 and 8, the biggest number won't be 6. You always check with 6, then start going down. 5, no. 4, no. 3, no. 2. 2 is the biggest number. And then they have 4 copies of x in common and no y's. So my GCF is 2x to the fourth. To get what's left, I divide by 2x to the fourth. And I would get 3 here, because that would cancel, plus 4, those cancel, y squared. And I'm done. Okay, on 2, there's no like terms, so I see 3 terms. I'm going to look for a GCF out of 4, 12, and 16. Always check the smallest number. 4 works. My letters, I have x squared, y cubed, x. Yeah, if you want to know, I mean, when you don't have anything, that second one would be x to the 0, y to the fourth, and the last one is x to the first, y to the fourth. So when I pick my smallest degrees, I got to pick x to the 0 and y to the third, which just means, I mean, x to the 0 is 1. So my GCF is 4y cubed. So 4y cubed, to get what's left, I divide by 4y cubed, 4y cubed, 4y cubed, and I get the 4's cancel, x squared drops, y to the 0, minus 3, y to the first, plus 4, x, y to the first. You don't need the 0 degrees in there, so 4y cubed times x squared minus 3y plus 4x. Okay, and if you multiply that back out, you get what you started with. Alright, so on 3, again, I'm going to look for a GCF. I got 12, 10, and 20. I'm going to start with 10 as the smallest. That don't work. 9, no. 8 doesn't go into all of them. 7, no. 6, no. 5, no. 4, no. 3, no. 2, yes. So my GCF is 2. My letters, I have an x cubed, an x squared, and an x to the first. Smallest one is first degree, so my GCF is 2x. Alright, so if I do my GCF, to get what's left, I divide by 2x. That gives me 6x squared plus 5x minus 10. Alright, and I'm done. For 4, I see 4 terms. So I'm thinking that I need to, my instinct is to go 2 by 2, but then I noticed that I can combine, I have z squareds that match and I have w squareds that match. So I'm going to combine those. And 1 take away 1.49 would be a negative 0.49 z squared. 8 plus 17 would be positive 25 w squared. Now, if that minus was in the middle, I'd have difference of squares, because I know 25 is perfect, and 49 is perfect, and squares are perfect, and I can rewrite this. It's 25w squared minus 0.49 z squared. And now you can see easily I have difference of squares. Check it. The square root of 25w squared would be 5w. The square root of 0.49 z squared would be 0.7z. And again, just type that in the calculator. Don't type the letter, but just type the square root of 0.49. It'll give you 0.7. So it's perfect, which means bino, plus n, mino. And my terms are the roots. So 5w plus 0.7z and 5w minus 0.7z. And we're done. Okay, so on this one, on 5, again, I started going 2 by 2, and then I noticed I got both pairs that I can combine. So I'm going to have 15k squared. 10y squared minus 5y squared is going to be positive 5y squared. It's not difference of squares, so I'm thinking the only thing I got a shot at is GCF. Biggest number would be a 5, and they don't have any letters in common, so my GCF is just 5. To get what's left, I divide by 5, and I get 3k squared plus y squared. And I'm done. That's all I can do. Okay? Alright, oops, sorry, skipped one. So I got 20, I'm looking for GCF. 27, 12, and 9. I'm going to start with 9. 9 goes into those two, but not 12. 8, no. 7, no. 6, no. 5, no. 4, no. 3, yes. 3 goes into all of them. My letters, I have a z squared x squared, a z squared x squared, and a z squared. Oh, which means I could combine those. And I get 27 take away 12 would be 15 z squared x squared plus 9z squared. Alright, which still now is going to give me a GCF of 3z squared. Because this one has x to the 0, so I don't get to use any x's. So my GCF is 3z squared. Give me just a second. You guys want me back there or just okay, so my GCF is 3z squared. To get what's left, I divide by 3z squared by 3z squared. So to get what's left is going to be 5z to the 0, because 2 minus 2 is 0, x squared, plus 3z to the 0. Well, that's going to give me 3z squared times 5x squared plus 3, because those are times 1s. Okay? Alright, 7. Initially, I started off trying to do 2 by 2, and I'm not going to waste your guys' time by showing it, but I got all the way to GCF, but when I tried to GCF again, I didn't have a common GCF. So that told me that you can't factor that way, which you should always look for a GCF first anyway, which would have solved all of my problems. Alright, so I'm looking for a GCF. I can tell it's 5. Okay, the smallest exponent of an x is going to be an x to the first. The smallest exponent on any y is y to the first. So my GCF is 5xy. To get what's left, I'm going to divide by 5xy. And what's left is going to be 5 divided by 5 is 1. X cubed divided by x to the first is x to the second. Y to the 2 minus 1 is y to the first. 10 divided by 5 is 2. X to the 1 minus 1 is 0. Y to the 1 minus 1 is 0. Minus 15 divided by 5 is 3. X to the 2 minus 1 is 1. Y to the 2 minus 1 is 1. Minus 5 divided by 5 is 1. X to the 1 minus 1 is 0. Y to the 2 minus 1 is y to the first. Alright, so now clean up all those 0 degrees, and I have 5xy times x squared y plus 2 minus 3xy minus y. And we're done. Okay, number 8, I'm going to look for a GCF, 8, 16, and 12. I'm going to start with 12. 8 is the smallest, does not go into all of them. 7, no. 6, no. 5, no. 4, yes. Okay, then I have x to the 4th, y to the 5th, x squared, y to the 1st, x cubed, y cubed. And I look for my smallest degrees. Smallest on x is a square, smallest on y is a first, so my GCF is 4x squared y. Excuse me, so I have 4x squared y. To get what's left, I divide by 4x squared y, 4x squared y, 4x squared y, and what's left is going to be 2x to the 2nd, y to the 4th, minus 4x to the 0, y to the 0, plus 3x to the 1st, y to the 2nd. Clean up the zeros and I get 4x squared y times 2x squared y to the 4th minus 4 plus 3xy squared. Okay? Alright, number 9. Again, I am tempted to combine like terms, but since there's not two sets, I'm going to do grouping. So 2 by 2. Alright, and GCF this side would be x. So if my GCF is x, to get what's left, you divide. That's going to leave me x plus 3. My GCF on this side is, I always take that first sign, so negative, and they have a 5 in common. So to get what's left, I divide by negative 5, which is going to give me x plus 3. GCF again by whatever common bino you have, which is going to be x plus 3. To get what's left, I divide by x plus 3. And what's left is x minus 5. Okay? On 10, again, we're going to look for a GCF. You have 72 and 60, and I'm not starting with 60 and going backwards. So I just start with, I know that, let's see, 1 goes into them, 2 goes into them, 3 no, 4 yes, 5 no, 6 yes, 7 no, 8 no, 9 no, 10 no, 11 no, 12 yes, and the rest are no's. So my GCF is 12. My letters, the smallest degree on any of them is the first degree, so it's x, y, z. So my GCF is 12 x, y, z. To get what's left, I'm going to divide by 12 x, y, z. And when I get what's left is 72 divided by 12 is 6. X, 4 minus 1 is 3. Y, 2 minus 1 is 1. Z, 4 minus 1 is 3. Plus, 12 goes into 60 5 times. X to the 0, y to the 0, z to the 0, which just gives me 12xyz times 6x cubed, yz cubed, plus 5. Okay? Alright, on 11, I can notice that I can combine these two and I can combine these two, which gives me a negative 14y squared z minus 14yz. And then I can do a GCF. Okay, and you can tell they have a negative 14 in common, one copy of y and one copy of z. So my GCF is negative 14yz. To get what's left, I divide by negative 14yz, negative 14yz. I get a positive 1, y to the first, z to the 0. I get a positive 1, y to the 0, z to the 0. And get rid of the zeros, I got negative 14yz times y plus 1. Okay? On 12, I have difference of squares. If the ends are perfect, the square root of 4x squared is 2x. The square root of 16y squared is 4y. So bino, plus and minus. And my terms are 2x plus 4y and 2x minus 4y. Okay, 13. I'm going for 4 terms, so I'm going to go 2 by 2, 6x squared plus 15x minus 14x minus 35. Split it. I'm going to GCF on this side. Biggest number that goes into 6 and 15 is not 6, 5, nope, 4, nope, 3, yep. And they have 1 copy. Smallest degree of x is 1. So my GCF is 3x. To get what's left, I divide by it, which is going to be 2x plus 5. My GCF on this side, oops, I don't know, really the wrong thing. My GCF on this side, biggest number that goes into, so starting with 14, no, 13, 12, 11, 10, 9, 8, 7, yes. And they don't have any copies of x, so my GCF is 7, and I always take this guy's sign, so negative 7. To get what's left, I divide by negative 7, and I end up with 2x plus 5. GCF again, which is going to be the matching bino, which is 2x plus 5. To get what's left, you divide by 2x plus 5. And what's left in green is your second binomial, 3x minus 7. Okay? On 14, I'm looking for a GCF. I got a 7, a 13, and a 27. 13's prime. So my GCF for those numbers is 1. My variables, I got an x cubed, z squared, an x squared, z squared, an x squared, and a z to the first. So my smallest x is a second degree, smallest z is a first. So I got x squared z is my GCF. My GCF is x squared z. To get what's left, we divide by x squared z, x squared z, x squared z. And I'm left with 7x to the first, z to the first, minus 13x to the 0, z to the first, plus 27x to the 0, z to the 0, which gives me x squared z times 7xz minus 13z plus 27. Okay? Alright, 15 is difference of cubes. So check if they're perfect. The cube root of 64x cubed is 4x. The cube root of 27y cubed is 3y. So they are perfect, which lets me do bino, trino, minus, plus, plus. My terms in the bino are the 4x and 3y. To get the trino, we square. That's going to give me 16x squared and 9y squared. And to get the middle, you multiply these two together. 4x times 3y is 12xy in the middle. And we're done. Okay, for 16, I've got 4 terms. Alright, but you should always look for a GCF first. Okay, 16, 4, 8, and 20. Look for the smallest. 4 goes into all of them, so 4 is my GCF. Look for the smallest degree of x. I got a 4, a 3, a 2, so it's going to be x squared. Smallest degree of z, I got a 3, a 2, a 2, and a 3 is going to be squared. So my GCF is 4x squared, z squared. To get what's left, I divide by 4x squared z squared, 4x squared z squared, 4x squared z squared, 4x squared z squared, and I get what's left is 4x to the second z minus 1x to the first z to the 0 minus 2x to the 0 z to the 0 plus 5x to the third z to the first. Clean up the 0 degrees, so I have 4x squared and 4x squared z squared times 4x squared z minus x minus 2 plus 5x cubed z. Okay. Oh my goodness. Alright, so on 17, I'm seeing 4 terms. So I'm going to go to 2 by 2. Okay, then we got a GCF over here. And if I GCF over here, the biggest number is a 2 and 1 copy of x. So to get what's left, I divide by 2x, which gives me x plus 6. On the other side, which leaves me x plus 6. On the other side, if I GCF over here, it's negative 9. Always take this guy's sign. So negative 9, and that will leave me, divide by negative 9, x plus 6. My GCF again is x plus 6. To get what's left, I divide by x plus 6, and what's left in green is my other binomial, 2x minus 9. Okay, on 18, they're doing a little trick here. My instinct is they've got a matching binomial on both sides, but I can't see because I need to simplify this. And that's going to be 2x minus 5 times 3x minus 4 plus 2x minus 5 times 3x plus 1. And you're looking for a matching binomial on both sides of that plus sign. And I got one. It is 2x minus 5. So that's my GCF. So 2x minus 5. To get what's left, I divide by 2x minus 5. And what's left is what's in green, which is 3x minus 4 plus 3x plus 1. Combined like terms is 6x minus 3 times 2x minus 5. Alright. We got sum of cubes. So see if they're perfect. I got the cube root of 125x cubed, which would be 5x. I have the cube root of 343y cubed, which is going to be, what was it, 347. I just typed it in the calculator. Okay, so they are perfect, which means I can go bino, trino, plus, minus, plus. My terms in the bino are 5x and 7y. To get the trino terms, you square. That's going to be 25x squared, and that's going to be 49y squared. And to get the middle, you multiply those two, which is 35xy. Give me just a second. And okay, so we're done on 19. So for 20, again, my instinct is to combine like terms. But again, 4 terms, we're going to split it 2 by 2. So I have x squared minus x plus 2x minus 2. That splits in half. GCF, GCF, GCF again. Woo! So if I GCF this side, all they have in common is an x. To get what's left, I divide by x, which leaves x minus 1. GCF the other side. The only thing they have in common is a 2, so divide by a positive 2 to get what's left, and you get x minus 1. Sorry. GCF again by the common binomial, which is x minus 1. To get what's left, divide by x minus 1, and what's in blue is your second binomial, so x plus 2. Done. Alright, try this one, hit pause, come back when you're ready, and hopefully you got A. This is difference of squares. So the square root of 144 x squared y squared is 12xy. The square root of 169 z squared is 13z. So bino, bino, plus and mino, and your terms are these guys. So 12xy plus 13z and 12xy minus 13z. Okay, and the order doesn't matter. Okay, try this one, hit pause, come back when you're ready. I see 4 terms, so I'm thinking grouping, 2 by 2. So 6x squared plus 27x is on one half. The other 2 is negative 14x minus 63. GCF, biggest number 6, no, 5, 4, 3, and 1x. So my GCF is 3x. To get what's left, I divide. 6x squared divided by 3x is 2x. 27x by 3x is positive 9. Sorry, I'm forgetting to change my colors. On the other side, my GCF is going to be 7 and no x. And I'm going to use a negative because the first guy's negative. So my GCF is negative 7. To get what's left, I divide. And I'm left with 2x plus 9. GCF again by 2x plus 9. To get what's left, you divide by 2x plus 9. And what's left in blue is your second binomial, 3x minus 7. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got C. Okay, I'm looking at 4 terms. And I'm not seeing grouping, so I'm looking for a GCF. You got 24, 12, 16, and 8. Alright, starting with the smallest, 8, no, doesn't go into all of them. 7, no, 6, no, 5, no, 4, yes. And then my letters, I've got x cubed y squared, x squared y squared, x cubed y cubed, x to the 5th, y to the 4th. So I'm taking the smallest x and the smallest y, which are going to be squares. So my GCF is 4x squared y squared. So there's my GCF, 4x squared y squared. To get what's left, I'm going to divide by 4x squared y squared, 4x squared y squared, 4x squared y squared, 4x squared y squared. And what's left is my second factor, which is going to be 6. X to the 3 minus 2 is 1. Y to the 2 minus 2 is 0. Minus 12 divided by 4 is 3. X to the 2 minus 2 is 0. Y to the 2 minus 2 is 0. 16 divided by 4 is positive 4. X to the 3 minus 2 is 1. Y to the 3 minus 2 is 1. Negative 8 divided by 4 is negative 2. X to the 3rd. Y to the 2nd. Get rid of the 0 degrees and I end up with 4x squared y squared times 6x minus 3 plus 4xy minus 2x cubed y squared. Okay? Alright, if I factor this one, this is one of those weird ones where they're trying to get you to see 2 things on each side of that plus sign. I need to clean this one up, which is going to be y minus 2 times 2y plus 3. And over here I have y minus 2 times 1, if you will, just so that it looks like there's something else over there. And you can see the common bino is y minus 2. So my GCF is y minus 2. To get what's left, I divide by y minus 2. And what's left is 2y plus 3 plus 1, which gives me y minus 2 times 2y plus 4. Which is not the answer. Come on, where's the answer? And the reason is because what happens is, if I look at this factor, okay, they have something in common. There's a GCF in there of 2. So if I factor out a 2 to get what's left is y plus 2, and I still have this guy. So my answer is 2 times each of those. Alright, it says when 9x squared minus, try this one, hit pause, come back when you're ready. Hopefully you got 6x. It says when 9x squared minus 16 is completely factored, what is the sum of the factors? Well, this is difference of squares. The square root of 9x squared is 3x. The square root of 16 is 4. So bino, plus and minus. 3x plus 4, 3x minus 4. Those are the factors. Well, it says what is the sum of the factors. So it's telling me to take the factors and add them. So 3x plus 3x is 6x. Positive 4 minus 4 is 0, which is just 6x. And we are done. So I will see you next time for day 6.